sections. So slideshow.
Why is every section your favorite?
I just like math. I love math. It's all fun. It's always fun. The only thing I hate are those fractions. No, I don't. You know what I dislike? Decimals.
No, you don't. I don't like the decimals.
No, I
You
don't.
probably enjoy like making percents and all that stuff.
Touche. I do. I like it all. All right, so factoring, special type of factoring. And the reason why I like the special type of factoring is because there's these rules. And it's kind of like little cheats. And if you can see the patterns, you can see the rules, then the factoring part is so easy. Okay? So we're going to try to get through all of it. Wait a minute, did we finish 6.2? No.
I don't think we did.
I don't think we did. We started it, right? My bad.
Well,
Let me take a look at it, because
we're just doing examples. So
now that I think about it, I don't even think we finished this one. Let me get through this.
Are you serious?
Nope. So we had to finish this. So let's finish 6.2. So I got to change this video to 6.2, part B. Let's see here. Where did we start off at? We did that. Did we do this one? Yeah, we did, huh? Factor out a common factor. And then let me go from here. Current slide. Okay, use an alternative method for factoring trinomials. An alternative method for factoring trinomials. Let's take a look here. Well, I think this was the Xbox method that they were showing us. Or is it? But, did we get through these slides? We did, huh? Where I showed you guys the trial and error piece of it. So we're good here. Let me skip through this. Try some possibilities, which is the one I like the best. Okay, let's see if you guys remember how to do this. Let's try this out real quick. Okay? So here's what I'm going to do. First thing I'm going to notice is that this number up front is a -2. That means it's a prime number. The only way to get that is going to be a -2 and a 1. So I already know that these are static. Those aren't going to go anywhere. Okay? So now I just need to try to mess around with the factors of 12. Now, do I want to start with 1 and 12? Do you think that's even going to be an option? No way. No way. So maybe I want to try something else like the 3, 4, because there's a 3, 4, right? 3, 4, and 2 times 6. I know this one's not going to happen at all. So which one do you guys want to try? 3, 4 or the 2, 6? The 2, 6? And is there an order that you want them in? The 2 first and then the 6, or the 6 first and then the 2? All right, so I'll just go 6, 2. Does that work? All right, so let's see here. The outside product is a -4, and the inside product is a 6. It looks like that's going to get me +2. That's not what I'm looking for, is it? So I'm going to swap them. So I'm going to swap that. This is going to become a 2 and a 6. So it looks like I've got -12 with a 2, and that's a difference of 10. So it doesn't look like 2, 6 is going to work for us. So I can eliminate that. Let's try the 3, 4. Any order you want them in?
4, 3.
4, 3. So we'll go 4, 3. 2 times 3 is a -6. That's going to give me a 4, which is a difference of -2. So it looks like it might not work that way. If I try the other one, what was it, 4, 3? If I go 3, 4 now? 2 times 4, that's going to give me a -8. And the inside's going to give me a 3. And there's my -5. So there's the order. I just need to add my signs, and I'm good to go. Okay? Questions there? We good? Awesome. Factor this. Let's see here. I think you guys get the idea of the factoring bit, right? Factor by substitution. They want us to factor this. Okay, I already showed you this, didn't I? The use substitution idea. So we can move on with that. Oh, that's it. Cool. So we are done with that. All right, cool. 6.3. Yeah. From current slide. Okay, so go ahead and write these objectives down if you want. We are going to go through them one by one individually, so you should be okay with that. All right, so factoring the difference of squares, a perfect square trinomial, factor the difference of cubes, and the sum of cubes. Now, for the first two, you're just going to have to recognize those and then know what the pattern's going to be. For 3 and 4, you actually need a formula, but it will also give you that pattern. That will always work for you as well, okay? And those are really easy to identify. So let's go ahead and get started here. Talking about the difference of squares. The difference of squares looks like this. It's something squared minus something squared. Okay? If you have a difference of squares, then you can factor it into these two binomials, which are called conjugates. Notice that the only thing that's different between them is the sign in the middle, right? You got x plus y and then minus y. Plus y and then minus y. The difference of squares will always factor into two conjugates, or into a set of conjugates. For example, p squared minus 100. Well, 100 is not a square, is it? But we can make it look like a square, because this could be p squared minus 10 squared. You see it? So you have to be able to recognize that. Which at this point becomes super easy because that's going to factor into p plus 10 and p minus 10. And you're done. Easy? Easy. What happened? Oh, did you sneeze? Salute. Are those sugar wafers? Those were my favorite as a kid too. The strawberry ones.
Strawberry heart.
I feel like they all
They have
taste the
chocolate
same.
ones.
No, they don't.
No, they don't.
It's like water. Does all water taste the same?
No.
No.
You're right.
But you have to be, I guess, passionate about something. Like really have it often to taste the differences. All right, cool. Can I move on here? Let's try this next one here. This one says 2x squared minus 18. Hold on. I'm looking at 18. That's definitely not a square, huh? And neither is 2. Fantastic. So we can take out that common factor of 2, and that would leave us with x squared minus 9. Oh, now that's the difference of 2 squares. Nice. So that would give you x plus 3 and x minus 3 once you factor that out. Ducky. Okay here?
You're okay.
Sha, thanks. Alright, let's move on. Oh, there's one more at the end. Same idea here. Same idea. Let me erase some of this so you guys can see that bottom one. In this bottom one, you're not actually factoring on a common term because 9 is a square. So what you really have here is 3a squared minus 4b squared. Okay. So when you factor that, it's going to look like this. 3a plus 4b, 3a minus 4b. Mucho cansado. We're good? Change it? No? Thank you. You too, Steve? Okay. How about this one? What can we do here? You try it out. Who's got this one? You're done? Nice. You want to do it? Oh, wait a minute. Never mind. I'm done. This one's going to be a little weird because it's going to look like it factored into two trinomials. How many people got two trinomials? Okay, it's going to look like this. M plus 3 plus 7z. M plus 3 minus 7z. You guys see that?
72. Why can't you just square it?
Because you're just trying to factor it. Now, the reason it looks like this is because the m plus 3 happens to be the first number. And it's really this. So look just like the last ones, right?
It's a Z.
There's a line through it. Yeah. Thank you, Fancy 7. Mark. How about here? Try that. Y to the 4th minus 16. Please factor completely. You're looking at it like, really? Really, Munoz? Really? Really? That's what you want me to do? Really?
That's right.
Oh! I'm going to pick somebody to do this one on the board. So let's have Dojo run. Go Dojo. Go Dojo. Where are you at? Oh. That's somebody's app. It's a shopping list app.
Wait, someone did that in your class?
Everybody has to do it in my class. But they messed up, so they had to redraw some buttons. Okay, let's see here. First period algebra. So we're looking for the y squared plus, what, minus 49? It's going to go to Micah. He did double check. What'd you come up with, Micah? Y to the 4th. What was it? Y to the 4th minus what?
16.
Oh, making it up. 49. I'm crazy. Micah, what'd you get? Okay, we'll wait for you. We'll wait a little bit more. We'll wait a little bit more, and then
Wait,
I think I deleted it. What?
Who messed up?
They didn't really mess up. They deleted some buttons accidentally, and then they had to redraw them. That's why they looked. Oh, I got rid of it now. Oh, but here's one.
On
So-
Thursday when you asked Angelo and him if they were done, he said yeah, and his whole screen was like blank. He was like, yeah.
Well, he has to email me anyway, so if he doesn't do it.
No.
So here's what it does. They can add an item. So what would you like to add? Eggs, and then puts it over here. Add another item. Flour. Add
Why did you give them so long to do that?
bacon. Huh?
You gave them like 2 weeks to do that.
No, they get 1 week.
But you pushed it out.
Not this one. It was the guessing game. It was a different one. They have to make. They're making every week. They have something due, and whatever they don't finish in the week, like they turn in whatever they have on Friday that week, and if it's not correct, then I give them another week to fix it. If they didn't turn anything in that week, then they don't get points for it. We can show you. I can show you later. We're gonna get back to this problem, and I'm actually gonna spin this again. So we might get somebody new. So let's do this again. Everybody have an answer? Who does not have an answer? And you were asking me questions about. Okay, I see. You're stuck. You're stuck. Where'd it go? Oh, that's something else. These are funny. These will make sentences for you.
I feel like I would do better in that class.
I don't say it.
It's different. And it's not as easy as it looks either. I mean, I thought it was going to be easy, and like some of them give me a hard time. Where did it go? Where did my dojo go?
You have too many. It's over there.
Because I have to grade everybody.
Oh, it's right there.
There it is. All right, so we'll close this one off. We'll let Mike off the hook. If you get call this time, Micah, that's you. Here we go. Christopher Corbin. Come on, bud. You can do it.
I'll put y plus a squared. Not a squared, but like I'll put parentheses and then put square on top of that. Can you do that or not?
Y to the fourth?
No.
Y squared squared?
No, I said y plus a. And then put the
Oh,
square.
you just went to the answer? Is that what you're doing?
Oh.
Y plus 8?
Yeah, parentheses. And I put a square on top.
I want to show you what this would look like if expanded. If this was expanded, this would become y squared plus 16y plus 64. Is that what you wanted to do?
Oh no, and then I was going to say y and then another parentheses, y minus 2 parentheses, square on top.
So you had y plus 8 times y minus 2, like this? Yeah, that? That would get you to the fourth, but it would be a big... Before I even say anything, this is going to become y squared minus 4y plus 4, and then I have to multiply that out. So 4 times 64 is 252. Okay. So that was a good attempt. Let's see here. Thank you, Christopher Corbin. Next person to try it out, Ruben Altamarino.
I did the same thing. Except for I put I did the same thing and I never changed it, but I put y squared in the parentheses instead of outside.
Y squared in the parentheses.
Yeah. And I did 4 in each one. Like plus 4.
Plus 4.
Yeah.
So you went y squared
Plus 4.
plus 4
Yeah.
and y squared minus 4.
Yeah.
Okay, that's good. That's a good start.
Right?
It's not wrong,
Would it be,
but it's not factored all the
would
way.
it be y plus 2 and then y minus 2 and then y plus 2?
Yes and no. Okay, hold on. Before I forget.
Or could you do y plus 4 squared Like in y plus 4 parentheses and like a squared outside of it?
No, because that would be that whole thing times itself. I see what you're saying, but this, here's what we got. What you said about this was true, Josh, because that's also the difference of squares, isn't it?
Yeah.
So that would be y plus 2, y minus 2. Do you see it?
And then,
So you're from what you said, you're saying that this should also be
the same.
2 conjugates.
Yeah.
Now let me ask you this question: is this the difference of squares?
Or could it would be negative, negative, or positive, positive?
Okay, well let's see. You're saying, well maybe that could be y plus 2, y plus 2.
Yeah.
Okay. Let's see what happens when I multiply this out. Y times y is y squared. That's 2y, that's 2y, so that's a 4y plus 4. Is that what I had? So can I factor it this way? Well, maybe the minuses?
Yeah.
Maybe the minuses? Okay, so if I went y minus 2, y minus 2, that would give me y squared for the inside. Negative 2y, so it'd be negative 4y plus 4. Is that what we want to break it up into? Okay? And I'm glad you said that because everybody needs to hear this. This y plus 4 cannot be factored. It cannot be factored. Okay? Actually, let me correct myself. You cannot factor that with real numbers. Okay, if you try to factor that, you're going to get imaginary numbers. Okay? So one more time, that would factor into imaginary numbers. You'd get y plus 2i and y minus 2i. Okie dokes. But you haven't done imaginaries for a while, right?
Yeah.
But you could. But the other part is definitely factorable into real numbers. So please put this in your notes somewhere. That's why we said the difference of squares can be factored, but not the sum of squares. Not the sum of squares. Sum of squares would give you imaginary numbers. Do you need me to look away?
What did you say? The difference of squares?
Yeah, the difference of squares. So like this one. This is the difference of squares. This is factorable. This one, not factorable. And I shouldn't say not factorable because it is factorable, but you would get 2 imaginary values for that.
What's this whole equation altogether is not factored?
Say that one more time.
So why 4 minus 16 is not factored?
Yeah, it factors into this right here.
So that's the answer?
Yeah, that's how I would leave it, like this middle one. Right. What I was doing below was trying to humor Josh and factor the sum of them, which is not doable. So that factors into this. Okay. But yeah, again, if you want to factor this, you know, because you've learned this in algebra 3-4, right? That would give you y plus 2i and y minus 2i, y plus 2.
But you don't think we would have to do that?
Not right now. Not right now. Once we go back over imaginary values or complex numbers, though, you can do that. But for now, don't worry about it. Okay?
So if we come to another problem like this, we just like leave it in front like that.
Leave it like this top one.
Okay.
Leave it like the top one. Okay. All right, moving on. That's not the right one, is it? There we go. From current slide. And there it is. Okay.
Oh.
All right, here we go. Here's where you need formulas. Factor a prefect.
What?
Fail. Factor a perfect square trinomial. Okay, please. Write these formulas down. Write these 2 formulas down. This is when you're factoring a perfect square.
Wait, don't change it yet.
So when you're going to factor a perfect square, And you guys should recognize these numbers already, right? You guys recognize them from Pascal's triangle? 1, 2, 1, and then you got 2, 2, 2. Sha. You guys ready? All right, cool. So here's our first example. Before you jump into it and try to factor it, you have to first realize or try to decide whether it is going to be a perfect square or not. And here's the way I do it. Take a look at this first term. What's the square root of it? 7z. What's the square root of this? It's 1. Multiply the two. 7z. And if you double it, do you get the middle one? Well, technically no, right? But that's okay because I can do this, can't I? Now, does that work? If I square that, it gives me that. If I square that, it gives me that. 7z times negative 1 is negative 7z. And if I double it, I get negative 14z. Does that work? And you're done. Only if it follows the rule I just gave you. If it doesn't follow that rule, then it's not going to happen.
So is this one of those things where you say it's not going to work for everything, but you're wrong and it works for everything? No?
There was some.
I'm being serious.
Here's what I said. Take the square root of that, and you got 7z, which is a good start. Sometimes it doesn't have a square root, which means it's not going to be a perfect square. But here we had a square root as well, and then I tried it. This times this, and then I doubled it. And that gave me the negative 14. So, square it, and you're done. Because that's really what it is. Okay, all I'm doing is modeling that equation. I'm going to show you that equation again real quick. See that? So I take the square root of this x, take the square root of y, that would give me x times y, right? And if I double it, I get 2 times xy. So I'm just modeling the function there, or the equation. I'm trying to, so that you understand what's going on. Want to see it again? You guys gonna try this one? So here's the process. What's the square root of the first one? 3a, right? How about the second one? 8b? All right, so here we go. 3 times 8 is how much? And if I double it, do I get 48? Good to go. Math. Thank you. Are you guys fighting on your cell phones?
No.
Oh, they kind of look like that because when you put it down and she picks it up.
No,
And
she
then,
just gives me dirty looks for no reason. I don't understand.
oh.
It's the morning. That's what she'll say.
Let me wake up. That's funny.
You could wake up next to her.
Ow.
Okay, try this. Way to ruin it, you ruiner.
They can't just. So what should we make sure you can do? It's extra.
Yes. Can we do this one?
Huh?
Here. Can we do this one?
Are you already stuck? Try it. Try some stuff.
I just don't know what the first step would be. That's what gets
What's the score to the first one?
X.
Score to the second one.
There's not a square root.
Oh, what did you do with the
Oh
y?
no, I got it.
Did you start with the y?
Wait, no.
Yes.
Oh, see, that's
Instead of the
I
one?
can't. I don't know. Like,
The last one's actually a quantity. It's the 1 minus y squared because one squared is just 1, isn't it? See that sneakiness?
I'm in pen today, so I can't like make.
Oh, here, I'll show it to you. It's going to be cleaner this way. So here, you do this. Okay?
Alright.
And this is what you're going to look at. See how that's the square I said? So that's going to factor into this. Ever see that?
Yeah.
No?
Yeah.
All right.
Yeah,
So,
yeah, yeah, yeah.
okay, good. And then now what you have is another difference of squares. So what happens with difference of squares? They become two what? Starts with a C. Conjugates. So you're going to get the x minus 1 plus y and the x minus 1 minus y.
Okay, leave that right there.
Oh, they kind of snuck something in there for you real quick. You good, your kid? You want me to explain it again? Here.
Like I have that one.
Oh, you got your new. Yeah. All right. So if you have a question, you need to ask. Don't take it on the eraser. Oh, watch out. I got the boss water.
She always has lots of water.
I tried Voss one time, and it wasn't that great.
It's all water.
Water's all different. Like Arrowhead is disgusting.
Oh,
That
yeah.
is the worst water you could ever.
I call that bear urine.
That's disgusting.
You know how they say it's water from the, what are they from?
Like,
The,
literally,
I think they literally go to the creeks and just do this. Bottle it!
It is. It's really just. that
It's
is the
bad.
worst water I've ever drank.
It's got the worst aftertaste.
no balls. No balls?
Best water in town, though. Water and ice.
Then there's one more stupid thing.
Water and ice on Orange Boulevard.
We
Amazing.
got it in a shake.
And Aquafina's best water. Oh, yeah. Aquafina? Better than that Dasani.
Don't make threats.
I don't drink.
No, it's not.
I don't like threats.
No, it's not. Then Aquafina?
It's not, but.
It's amazing. It's the best. Okay, hold on. We're not done. We got one more. Don't pack it up. Oh, snap. I got 3 minutes.
Don't do
Okay.
it. Don't do it.
Don't do it? Okay. Let me end this then.
I'm like.
Oh, because we did the